EIGRP design over frame relay. Frame relay always ranks at the top of the list of confusing topics when it gets to Cisco certification. So before we dive straight into the EIGRP design, I want to do a flyby review of everything frame relay in just a couple minutes. So frame relay is actually the second generation technology of packet switching. It started with X25, ended with ATM, and now everything's kind of falling into MPLS, which isn't really a technology that's used at customers at all. It's just service providers as whatever comes in there. Could be frame relay, DSL, cable modems, dedicated circuits, whatever. As it comes in, it gets converted to MPLS labels, which just makes it a lot more efficient for the service provider and gives them the ability to easily separate customers. So back to frame relay. Frame relay gave us an alternative to dedicated circuits. Before there was frame relay, we would have to buy, I need a T1 line from Arizona to Missouri. Okay, bing, $650 there. I need a T1 line from Arizona to Texas. Bing, $592. By the way, these prices change because it's based on distance and speed. So you add all these up, we just come up with a tremendous monthly reoccurring cost. Frame relay came to the rescue and says, you know what? You just pay for one physical connection and a much cheaper rate for all these permanent virtual circuits. That's the technology, right? The idea is that the service provider gets you all these different logical links over to these locations, each with their own committed information rate, which is usually billed a lot cheaper than dedicated bandwidth, because what the service provider does is oversell that. They say, okay, well, if you pay for a T1 committed information rate, we'll not only give you a little more, normally called bursting, than 1.544 megabits per second of bandwidth, but we can also resell that, unlike dedicated circuits, to where we over provision, and they do it carefully because they know all their customers don't use 100% of their bandwidth 100% of the time. So that's the whole, yay, waha, we love frame relay, but all that's kind of going away for MPLS. The big thing that we want to understand is how the DELCs work, because it's weird. We're used to MAC addresses in the Ethernet world, right, where we have a source. Let's just say it's 105, we would think as a MAC address source. I know that's not a MAC address, but pretend it is. And 501 is the destination. We say, okay, I'm sending data from this source to this destination. That's not at all how frame relay works. Frame relay has this concept of a DELC. So this is a layer 2 address, just like a MAC address is, data link connection identifier, which is bizarro backwards land. And this is where I start to tie it together with EIGRP. Let's say we have a PC in Arizona trying to talk to a server in Missouri. This is the 10.1.5 network, right, /24. Over here is the 10.1.1 network /24. So I'm saying, okay, my source, let's just say this is 10.1.1.50 going to 10.1.5.50, right? So if I were to ping it, so that's my traffic. I have a ping message that I want to send. I'm going to have the source IP address of 10.1.1.50. I'm going to have a destination IP address of 10.1.5.50, right? Now, as soon as that hits my routing table for Arizona, Arizona's going to be like, let's look it up. Oh, I get to 10.1.5.0, that network, by going to, let's just say this is 5.5.5.5 over here, right? This is the IP address of that interface. Over here, maybe I'm 5.5.5.1. So it looks at its routing table. It's like, oh, okay, to get to 5555, I've got to go out serial 0/0. And under serial 0/0 is a configuration that says, okay, well, if you want to reach 5555, by the way, this is called a frame relay map, right? If you want to reach 5555, you need to go to DELC 105. That's kind of the destination. Not even a destination, it's just the DELC, right? So I say DELC, put at the front of the packet will be 105. So when the service provider gets this packet, you know what it does? Rips it off. Doesn't make that noise, but it does the same thing. It rips the DELC off the front, replaces it with whatever, because it's already made the identification. All these things is a locally significant identifier, meaning in Arizona 105s means something than it would in California, or not 150, but 105. Don't do this. You can, by the way, you can do this. Have 105 here, 105 here, 105 here. Well, you can have 105s all over the place, as long as you don't have it twice in the same location, because they're locally significant. As soon as it comes in, the DELC has done its job. It says, I'm going to Missouri. And the service provider is like, you're going to Missouri. And it sends it out here. And when it comes out the Missouri circuit, it goes, plop, and puts a 501 right on the front of that packet, and it comes out and lands in the Missouri router. It's like, oh, hello, friend. You must be coming from Arizona because I see you coming from 501. It's weird. Instead of source destination, it's like I'm leaving out of gate 105 in an airport, flying out and landing and coming in terminal 501, right? It's just kind of a local landing spot for you. The other glorious thing of Frame Relay is we have complete flexibility over our virtual circuit design. We have, first off, the cheapest model being hub and spoke. That's where you have a hub connected to all these different spokes with permanent virtual circuits, right? It's cheapest because you pay for the least amount of links, but if you lose the hub, you lose it all since everything goes through the hub. Also, it adds some delay because we have to have Missouri come out to Arizona before it goes to somewhere like Texas instead of going directly like you would in the full mesh. Drawback of the full mesh is that it is the most expensive because you have virtual circuits connecting everything to everything, and you may have some offices, like for instance Missouri, where it isn't that critical. There's only a couple people that work there. If they drop off for a couple hours, no big deal, right? So in this environment, in the partial mesh, you essentially find a hybrid between cost and the redundancy to where California can always connect to Texas even if Arizona goes down, because Arizona is no longer the central point of failure with virtual circuit connectivity. Now we can talk about how EIGRP handles non-broadcast multi-access networks like Frame Relay. Answer: it depends. Depends on your permanent virtual circuit design, which is what we talked about just a moment ago, along with how you implement that PVC design, whether it be point-to-point or point-to-multi-point. Let's take that typical hub and spoke topology, forgive my terrible dotted lines there, that we have going from this hub over here to all these spokes over here on the left-hand side. Right? So when you set this up, let's just say this is your PVC design, and this essentially you dictate as you provision or purchase those circuits from the service provider, right? So the PVCs are set. How you implement those PVCs, whether it be a multi-point design or point-to-point, really dictates your EIGRP setup. Multi-point means that I take all those PVCs and stream them in to a single IP address. So this would be where I have 10.1.1.1 over here. Maybe over on this one I've got 10.1.1.2, right here 10.1.1.3. What do you notice about all these guys? I haven't given you a subnet mask yet, but let's just say the subnet mask is a /24. They're all on the same subnet, thus multi-point, thus blah, terrible. Don't do it. No, run. Don't set up a multi-point design with the EIGRP. Okay, you'll have to sometimes. Why? Because sometimes you're going to do a certification exam and they'll force you to do a multi-point design. Why? Because they know it messes everything up. So here's the problem with multi-point design. You run into split horizon issues and it just... I want to explode. It doesn't make sense. So first off, multi-point design makes the routers believe they're actually like this. Everybody connected to a switch where they're all on one subnet. Everybody can talk to everybody. But you know what? Looking at that cloud, can everybody talk to everybody? No, they cannot. Why? Because we have a hub and spoke design. We have all these spokes have to go through the hub to actually reach each other. So no, they can't talk to each other. So we have to play tricks to make them talk to each other. That's the game of multi-point. Split horizon can and will be an issue with multi-point. What is split horizon? It is the idea that an interface cannot receive a routing update and then turn around and send the routing update back out. It is a distance vector routing loop prevention mechanism. What it does is keep loops from happening from an advertisement going in and back out, in and back out, in and back out. But you know what? For this environment, you have to have it because they're going to come in this PVC, and you have to flip around and send it back out one of these PVCs. So what do? Disable it. That's right. Disable a loop prevention mechanism of the routing protocol core itself. Does that sound like a good idea to you? Am I passionate about this? Yes, I'm passionate. Don't ever use a multi-point interface because you're literally kicking the legs out of your stool and just trying to balance on, yes, there are other loop prevention mechanisms like triggered updates and all these different things that you may have learned from back in the CCNA days, but it's just not a good idea. Okay, so you've got to do it because the certification exam told you. What do you have to think about? Well, you have to first off think about disabling split horizon, and also you have to start manually mapping. So this guy knows about this guy. You actually have to manually map him through this one. It's just ugly. So obviously, I'm not just going to be a negative guy on multi-point. What's the right way to do it? Point-to-point design. So here's the idea. Same scenario. Now again, you don't have to talk with the service provider at all for any of these changes. It's just in how you set it up. Instead of going under one interface and setting up one IP address for each one, on the hub, you go in and you set up, we'll just say serial 0/0 with no IP configuration on it at all. Serial 0/0 dot, this is like router on a stick time for VLAN, let's just say 105. or 150, because that's what my pen wrote. 150, that could be the DELC number. It doesn't have to be, but that's actually the sub-interface number. And I'll use 10.1.1.1/30 right there. Great IP address conservation. And then over here, maybe I'll do a serial 0/0.151. Let's just say we've got DELC 151 here, 150 over here. Again, these don't have to match the sub-interface numbers, but good grief, why would you not do that? And on this one, we would do 10.1.1.2, right? Forgive my pen bleeding together. 10.1.1.2 on this side. And so it's a dedicated little point-to-point. I mean, logically, this router thinks, hey, I've got a connection from me, router 1, over to router 2 up there. Then over here on the second link, that's where I'll do, let's say this is DELC 160, right? I'll do serial 0/0.160, have 10.1.1.5/30. Why? Because I went into the next subnet. Over here is going to be 10.1.1.6/30, right? And we'll have, we'll say 161 over here on the other side. Again, each one of these feeling to the router like it's its own little point-to-point subnet between these guys, and that's how it's treated. You don't have to disable split horizon because it can actually receive an update on serial 0/0.150, and it's got no problem at all flipping back around and sending it out serial 0/0.160 because it sees them as separate interfaces. So you can design the frame relay setup however you want. However, the right way, or Jeremy's highly suggested way, is to do it using point-to-point sub-interfaces. Last thing, I forgot to mention this bullet. EIGRP can use pseudo-broadcast, meaning this frame relay network type is non-broadcast multi-access, right? So it's kind of like it denies broadcast, which is true, but EIGRP can send pseudo-broadcasts, essentially a multicast message that goes straight across that cloud and reaches the other side, pretending to be broadcast and forming neighbor relationships. Or you can go in and disable enable manual neighbors, where I actually go in and type your neighbor is this, your neighbor is this, and you type in the individual IP addresses of each neighbors. And you can see my little note down here. One manual neighbor statement disables multicast, disables this pseudo broadcast. So that means if you do one manual neighbor, you have to do neighbor statements for every single one. You now know how to design EIGRP over frame relay, but to solidify this concept, I'm telling you, you want to check out one of the nuggets on the implementation, implementing multi-point or implementing point-to-point EIGRP over frame relay. For now, I hope this has been informative for you, and I'd like to thank you for viewing.